This is a video from section 4.3. The directions say to sketch the graph of a function that satisfies all of the given conditions. So in example 1, we have f prime of x is less than 0 and f double prime of x is less than 0 for all x. So what does that mean? On the interval from negative infinity to infinity, f is decreasing. And on the interval from negative infinity to infinity, f is concave down. Okay? And so what is that going to look like? Well, if you notice, this is I claim the graph of y equals f of x. So I want you to notice how the function is decreasing and at the same time is concave down. And basically that's what you're looking for. You're looking for a function that's decreasing and concave down at the same time. And that would satisfy both conditions. So example 2. Suppose I had f prime of x is greater than 0 and f double prime of x is greater than 0 for all x. Well, f prime of x is positive means f is increasing on negative infinity to infinity. F is concave up, that's what this means, right? F double prime of x is greater than 0. So this is concave up. So f is concave up on negative infinity to infinity. Okay? And so the graph will look like this. So here's y, here's x. And you want it increasing and concave up at the same time. And so I would draw a picture that looks like this. And if you notice, it looks pretty much like the exponential function. So notice how that function is increasing and concave up. So I claim it, this is an example of such a graph that satisfies those conditions. Let's do example 3. Suppose f prime of x is positive, which means f is increasing, and f double prime of x is less than 0 for all x. Okay, so what that says is f is increasing on negative infinity to infinity, but at the same time, you want f to be concave down this time. So f is concave down. On negative infinity to infinity. So if I were to draw a picture of this, here's x, here's y. I would draw personally a logarithm, so that would do the trick. Or in fact, if it's true for all x, right? I could do that. That's an increasing function that's concave down. And in fact, over here, well, this one's okay because it's for all x, right? So notice how in the first one, or in this one, f is increasing on negative infinity to infinity, and f is concave up. Notice f is increasing on negative infinity to infinity, and f is concave up. And on the first one, f is decreasing on negative infinity to infinity, and f is concave down. So those are okay. And so for this one, let's come over here. Notice how f is increasing on negative infinity to infinity, and f is concave down. It works. Let's take a look at example 4. Suppose f prime of x is less than 0 and f double prime of x is greater than 0 for all x. So here's y, here's x. And so f is decreasing, and it has to be concave up, right? So I would look at something like this. F is decreasing, and it's concave up. So it satisfies both conditions. Now, what happens if we impose more conditions on this? So let's take a look at this example. Suppose I give you this one. We're going to do this one. So f prime of 0 equals f prime of 2 equals f prime of 4 equals 0. So right away that tells me 0, 2, and 4 are critical values or critical numbers, okay? Now f prime of x is positive if x is less than 0 or x is between 2 and 4. So f is increasing. F prime of x is negative if x is less than 2 and greater than 0, or x is bigger than 4. So it's decreasing on those intervals. And f double prime of x is positive if x is between 1 and 3. That means concave up. And then f double prime of x is negative if x is less than 1 or x is greater than 3. Okay. Now, let's take a look at the first condition. So over here, we can say this. F is increasing on negative infinity to 0 and 2 to 4. F is decreasing on 0 to 2 and 4 to infinity. okay, on those intervals, in other words. F is concave up on 1 to 3, and then F is concave down on negative infinity to 1 and 3 to infinity. Okay, so the main points we have are 1, 2, 3, and 4, it looks like. Here's y, here's x. So we have 1, 2, 3, and 4. Now, one point that I do also want to mention is about 0. So let's include 0, because at f prime of 0, we get 0. So that says the slope of the tangent line of the function is 0, right? So now what I'm going to do is I'm going to notice that f is increasing on negative infinity to 0. So f is increasing like so, and then up to 0. And then I notice that it's decreasing from 0 to 2. So it's going to decrease from 0 to 2. Like so. And then it's increasing from 2 to 4. So from 2 to 4, it's increasing. And then from 4 off to infinity, right, it starts to decrease. So we get something like this. Now, I want you to notice something. If you look at here, right, notice how the slope of the tangent line is 0. So I notice that f prime of 4 is 0. That's good. So we're going to check our conditions now. The slope of the tangent line at x equal 2 is also 0. So that's good. And the slope of the tangent line at x equals 0 is also 0. So we're good to go on the first condition. Now, let's come over here. Notice how f is increasing from negative infinity to 0. Well, that's good. It certainly is. And then from 2 to 4. Notice from 2 to 4, the function is increasing. So that's also good. So first condition met. F is decreasing on 0 to 2. So let's take a look. Certainly f is decreasing from 0 to 2. And, let's come over here. F is decreasing on 4 to infinity. Well, yep, f is decreasing on 4 to infinity. So we're good on here. And f is concave up from 1 to 3. So from 1 to 3, certainly the function's concave up. So that condition's been met. So we're good there. And then f is concave down from negative infinity to 1. That's true. And it's concave down from 3 to infinity. So notice that's an inflection, right? Because it changes concavity. So from here and then on and on and on, that's certainly concave down. So this condition has also been met. And so this is a graph that satisfied all of those conditions. And so notice how I mostly focused on 2 things for this, or well, I'll say 3 things. I focused on the fact that f prime of 0 equals f prime of 2 equals f prime of 4 equals 0. And then I focused on where the function's increasing and decreasing. I tended to worry about the concavity last. Okay, and so because concavity you can change, right? Because over here, if you wanted the function to be, let's say, concave up or something, what I would have done is I would have just done something like this, but that's not what it asked. It asked for it to be concave down, right? And so that's why I did this. Because if you notice, f is concave down from negative infinity to 1. So you wanted it to be dumping water. And this concludes this video. This is for section 4.3, and it's on sketch the graph that satisfies certain conditions. And so we worked out 5 examples. So, okay, thank you.